Hi guys, can everybody hear me all right? Can you hear me? All right, I love Ansible. So today they've asked me to come up and talk a little bit about Heat. Heat is the orchestration service that runs inside of OpenStack. So I figured what we'd do is we'd cover a little bit about me, and then a little bit about OpenStack, and then explain what Heat is before we dive right in, just to make sure we're all on the same page. So me, I'm an open source fanboy, unabashed. I've worked at Canonical, the guys behind Ubuntu, for a few years. I also worked for a few years at Red Hat, the guys behind Red Hat. Before that, I was pretty much playing around with CentOS and Fedora Core and Slackware, which I started out on about 20 years ago. So I've been really, really interested in seeing the way that world has developed, and communities do build up on it. One of the great things about OpenStack and Heat in general is the fact that it's open source, and it's used by a lot of different people in ways you really don't expect. And that's one of the things I'm a really big fan about. At Rackspace nowadays, I'm a DevOps specialist, which is pretty vague. I work for our professional services team. I implement and evangelize DevOps methodologies. I talk to customers about their requirements or their culture, that kind of thing. And I help them implement it. I know we got a lot of DevOps people from Rackspace here today. So these are the guys I work with, and we have a lot of fun doing this stuff. So a bit about Rackspace. You may have heard of us, probably have. OpenStack-based cloud hosting. We call it managed cloud. It's basically our way of doing our passion for support based on cloud services. A lot of numbers. Pause the video, look at them all. They're all pretty awesome. Let's say baseline OpenStack. It's a big community of software projects and people that are pretty much bent on delivering a stable, scalable, and free and open cloud platform. So infrastructure as a service, as well as a lot of the Elastic services that go around it. Open, everybody can work on it, community-driven, and it's one thing that we're really, really big on. OpenStack was founded, by the way, by Rackspace and NASA about 5 years ago, so we love it, been there since the beginning, and we're not going anywhere with it. Away from it, I should say. Now, Heat. Okay, so what we're actually here to talk about. Heat is envisioned by the OpenStack community as a central service to manage the deployment and orchestration and end-of-life, life cycle management of infrastructure, just like you would any other piece of managed code. It's buried deep inside of OpenStack. It talks with all the different components, very well integrated, and pretty much established as the interface to OpenStack's orchestration and also its metering capabilities. Very tied in with projects like Solometer, Keystone. I mean, it's a first-class OpenStack citizen. At the moment, it's definitely in use at Rackspace. We use it with our customers in production at scale every day. I believe HP uses it as well in their OpenStack-based cloud. Other companies, Pulsant, NTT, all of these companies, they have the opportunity to use Heat to orchestrate. It's all tied in. Whether or not they use it, I can't really say. I don't have that kind of insight into their organization. However, it's done us a lot of good, and we really enjoy doing it. As you can see, a lot of people, you can kind of tell who's using it by looking at who's actually contributing to it. Not sure if you can see these names up here, but we have Mirantis, which is a great SI, do a lot of private OpenStack deployments. Red Hat, also a big contributor, big backer of OpenStack Heat. Ourselves, of course, and then you see some other people that you may not know what they're doing with, like Huawei, big contributor to it. This is all from Stackalytics, so nothing big here. But it's an interesting community of people, of both vendors and users that have popped up around it. Right, so what Heat isn't. So Heat isn't a flashy tool. It's not something you're going to go, hey guys, I was using Heat yesterday. What do you think? So Heat is, it's an established and it's a standard part of pretty much any OpenStack deployment unless you turn it off. If you're working with a public cloud vendor who uses OpenStack, they either have Heat and they provide it as a service endpoint to you, or they may have turned it off for whatever reason. Maybe they haven't developed a product mindset around it, or who knows. But it's a standard part. This is not a flashy tool that needs to be sold or established. It's well underway. So where does Heat fit in with the tools that you're already using? So I put up this graph as basically the two sides of getting infrastructure up and running and managing it once it's up and running. The orchestration side, as well as the configuration management side. Now, Heat is not going to go in and replace your configuration management software. That's not its focus, that's not its goal. In fact, it goes out of its way to work well with configuration management software. Something like, well, Heat totally focused on orchestration, keeping the parts moving, making sure they all come up in the right order, make sure they're there when you need them and how much you need, making sure you can move those pieces around. On the other hand, Chef, configuration management, that's its focus. I find it to be a little bit clunky when it comes to orchestration. Knife is a fine tool. Knife Rackspace, great plugin. But in the end, it's still a little, it's pretty manual. But that's its job. I mean, that's what it's designed to do. Heat works very well with Chef. The same goes with Puppet. Puppet, great configuration management, works on a lot of different platforms, plays very, very nicely with Heat. Heat takes care of the infrastructure. Puppet takes care of the application running on top of that. And other things that kind of straddle the line a little bit, SaltStack, Ansible, these things very capable in what they do. But, you know, Heat has its advantages, whereas Ansible has its advantages. Two different approaches, two really actually very good products. Now, if you're running an OpenStack cloud, there's a lot of moving parts involved. And Heat, these are the ones that Heat will actually manage for you. Some of the, you know, I think one, maybe two of these are Rackspace specific, but they have analogs in any private cloud, including the private clouds that we deploy for customers. Things like cloud databases, for example. This is Trove. If you're familiar with the OpenStack projects, you have a Heat resource type. Plugs into the Trove backend, and you can use it to spin up, spin down, and also deploy copies of, and otherwise configure these service endpoints. You also have things like Marconi message queues, cloud load balancers, so LBAS inside of the OpenStack cloud. You can have these be managed and then also use them, for example, spin up a cloud load balancer as part of your Heat template, and then call on that load balancer object to find things to configure, like what's my SSL endpoint, what's my port 80 endpoint, all these kinds of things. Make it then available to the other logic inside of the template. And that applies pretty much to any object that's covered by Heat, and for the most part, all of our objects are covered. One little side note, you also have a Chef solo object, which allows you to configure Chef from inside of Heat. So you have a first-class citizen that is a Chef solo pointed at a kitchen, and then you actually do all of your configuration in one place, the same place that you do your orchestration. Right, so what does Heat actually look like? We've talked a little bit about what it does at a very high level. What it looks like, the main way you interact with Heat, in my experience certainly, is through a text editor. It looks like a big pile of code. It's a YAML-based, either YAML-based template. There's also, if you're familiar with CloudFormations, there's like a JSON-y, pearly-looking thing. I prefer the YAML. It fits my sensibilities a little bit better. So you have a YAML, a set of YAML definitions, and they're the same dictionaries you would see in an Ansible setup. You have your lists, you have your dictionaries, you have your you also have your first level resources. Now, what this does is provide a way for the client, and that's what we have at the bottom. Basically, the first command you learn, take an existing template, Heat, stack create, tell it which file you're going to be pushing, and then the name of your stack. Now, you configure this the same way you configure the rest of your cloud clients, just like with any of the Nova commands or anything. You got some environment variables to set. You should be used to that by now. If not, open a Developer Plus account. You basically take that code, push it up to the cloud, and you have a stack. Here we've taken a very simple three-tiered stack with a load balancer, a little farm of app servers, and then a backend database shared by them. All set up inside the template and deployed with one command. Now the cool thing about templates and infrastructure as code is that this is perfectly repeatable, right? So if you want to, you can spin up 5 of these, see which one, maybe make some slight tweaks to them, but maybe spin up 5 of them, one for each dev team, bring them up, all from one template. You just give them a different name. This can, of course, be automated. You can say, spin them up at 8 in the morning and shut them all down at 10 o'clock at night, because who's using that anyway? Your devs will love that, by the way. Now, another way you can leverage the fact that it's code is you can parameterize. So basically that means make parts of your code configurable at runtime. You can tune these knobs, and they can be either the flavors that your VMs are coming up as. You can pass them as variables at the command line. They can be the number of servers in certain resource groups. In this one, I've just, as an example, I've taken num servers in that previous stack and just made that configurable. So when I do run it, I pass a number of servers, and it spins it up. In this case, a nice, sensible, maybe a failover configuration behind that load balancer and cache that says good stack 01. Now, it is configurable, so you can do anything you want with it, right? So we have here, tell it to bring up 1,000 servers, it'll do it. I mean, it's not a problem. Well, for me, for Rackspace, it's maybe a problem for you. It's a way, basically a way to tweak any side of this. I would recommend in this case, however, to maybe look at scaling the database backend as well. Right, so the template itself, like I said, it's a YAML file. You can describe all the resources that your stack is going to have in there. You can describe auto-scaling groups. You can describe, you can describe database backends, any of these things. And these are what we call resources. The actual, the actual compute and database and load balancer and network resources that you're going to be using inside of your stack. All just YAML stanzas. You take them in. It's pretty easy to learn. Take examples. Maybe just steal some templates from us. We don't care. And just, you can deploy that as is. Now, the other things you have are the parameters, so you can set in your thing. Usually these are things like your SSH keys. This could also be things like what's, which GitHub repo are we going to be pulling our code from, or what's the chef environment variable we're going to be setting. Okay, deploy a stack of 20, or in the previous example, 1,000 servers, all pointing at our chef hosted stack. Let's see how much that costs us. Right. And the third concept, which we won't be covering very much, is outputs. Now, when you do spin up these stacks, it may be important to you to bring information out of that stack. What's the IP address of that load balancer, for example? Or what's the database password? I want to use it in a different stack and be able to reference that coming over. So all these things are defined in the template, and really the only interaction you have with the heat service is, when you push it up there and see if he takes it or not. Right. Now, the command line is not heat. So that's just your heat client. Heat is the service that runs like a pillar of reliability inside of your OpenStack deployment. The heat client, all it does, it's an easy Python client, a thin layer on top of the REST API that heat runs on. And it gives you things like we see here, stack create, which we saw earlier, stack list gives you the listing stacks, the list of the running stacks. And stack update, which is kind of interesting. If you have a running stack, you take the template that you're deployed it with, maybe you tweak something in it, you change the flavor of all the servers, for example, or change it on the command line, and then push it up to heat. And what it's going to do is it's going to replace the parts of that stack that you updated with the new configuration. Got to be careful. It's in the documentation for all these objects that when it gets updated, if it will get replaced. And that does mean what it sounds like. Any state you had on that cloud server is going to get replaced. But these are cattle, right? Who cares? Blow them away. So that's one way of interacting with heat. How we actually put it into our products and present it to our customers, first of all, like that as code. But we also have a part of our cloud portal. It's very similar to the OpenStack dashboard, if you've seen it. So we have an orchestration area in our cloud portal for our cloud customers. And there you can actually go in and see a nice little list representation of all the heat templates that we provide for our customers. Now, these are actually some of them pretty sophisticated heat templates and really, really good examples of how to write a nice big heat deployment. And they're listed out by task. You have things like Minecraft servers. You have things like Drupal. And then, as in the example here, you can choose a couple of different templates that are actually like parents of each other. One of them includes the other ones, of a multi-tier Drupal deployment or a single server Drupal deployment. There's some Windows-based templates in here because Heat works just fine for Windows, as long as your OpenStack cloud is actually configured to deploy Windows guests. It works fine with configuration management, as I said, which a lot of these actually leverage existing chef kitchens that are open, or they also have a tie-in where you can tell it where your upstream chef server is. A lot of good examples in there. There's also the ability in our dashboard to take a template that you've created and paste it into the text box and just deploy it that way. I don't know why you would do that instead of using the heat client, but maybe you don't have heat client installed and you just want to do it over the net or from your phone or whatever. So that's one way to do it. Another way that you can use this is to go into one of the existing templates that we provide and customize it before you launch. Now, vanilla OpenStack isn't a lot different. Like our heat implementation pretty much rides rides master in Git from OpenStack. And it's very similar in function, the OpenStack dashboard, to what we have. It doesn't have the extra build-out features that we've put in, but at the same time, you can look at your running stacks. You can upload templates to see what kind of environments you can create with it. You can customize templates that are in there. All in all, a very much similar experience on stock OpenStack that you would have on the Rackspace cloud. So one feature that we don't have, and to be honest, I don't really miss it, is the stack overview in the OpenStack dashboard. It's kind of a shape of things to come feature, and if you're running OpenStack, maybe install DevStack, or if you have a private cloud in your business, have a look at this. It's kind of interesting. If you deploy a nice big chunk of heat template, you can see a lot of nice curves here in the rubber banding, and it's actually pretty cool. Right. So opportunities for improvement on heat. So heat, it works now. We use it in production. In fact, new customer deployments that come up, one of the first avenues we always approach from the professional services angle is, would this be easier with heat? Because it ties in with our other strategic products, and it's just a good choice. And we know it's safe going forward. However, there's some issues that we've run into. Sometimes it's a bit bumpy. Getting post-install configuration with config management, for example. Getting Chef up and running isn't the problem, but if you have any kind of complicated Chef setup and you've got a lot of keys going around and any kind of fancy pants stuff you're doing with the cloud in it, for example, you have to remember that you're embedding YAML inside of YAML, which is then going to be put inside of a YAML file, right? So you got to keep that in mind. It's a pain. And until you get it right, you can do a lot of head scratching because cloud init debugging is not much fun, right? Another thing is the way, like self-healing. This is on the roadmap, actually on the official roadmap for heat upstream. And self-healing, we implement in different ways. We usually have monitoring services like New Relic, or I'm sure in the future Data Loop, that will alert us in some way, and we will handle those alerts ourselves. Now, the ideal way for that to happen would be for it to happen either with inside Ceilometer or another backend plugin that you can provide for heat. So one way or the other, I do think we need to tighten up the heat story as far as high availability and self-healing and stuff like that goes. And that not just for cloud servers. I'm talking about like load balancers and stuff like that. Be able to do that all from within the heat stack would be pretty nice. And people are working on it. And I think one of the major things that really needs to get fixed is that logo. So I don't know if it's an official logo, but it's the only one you can find on the OpenStack.org site. If we do have any artists or designers or illustrators in the crowd tonight, one way to get in free to any OpenStack summit is to do some upstream submission, and I think a heat logo would probably be quickly and seriously appreciated. All right. Speaking of contributing, one way that you can get involved is having a look at DevStack. If you want to get heat up and running and you don't happen to have your own private cloud sitting around, have a look at DevStack. If you don't know it, devstack.org. It's a way to basically take a beefy laptop and get a full OpenStack deployment up and running on that in VMs and containers and that kind of thing. It's a very, very interesting product. Doesn't always work the first time, but play around with it enough and you will, in an hour or two, you will have a nice working OpenStack deployment on your laptop to play around with. Includes heat, also includes Keystone and Neutron and all the other things you want to play around with. Another way is to have a look at our upstream GitHub repo. So all of those nice stacks you saw in our portal, those are available as part of our open source community. We have those in our GitHub repo upstream. Let's have a look at that short URL that PowerPoint butchered. And you'll see a lot of nice examples. Some of those get pretty fancy, like I said. Like you have a lot of clever tricks that they're using, but to show you how people actually either get around shortcomings or invent new functionality from these. Another thing that you'll see in there is some Rackspace specific object types that we use inside of Heat. And for me, that's not a bad thing. It's just kind of a reminder that Heat is extensible. Heat is something that you can write backends for. If you're in an OpenStack cloud and you want to put incoming requests out through whatever backend you want to use, yeah, it's pretty much in your hands what you want to do with it. And it's all Python, so come on, get to work. And of course, the last way would be to just sign up for a Developer Plus account. It gives you access to our version of Heat, and of course, all those templates and everything are in the portal. But it'll give you a chance to play with the stacks, play with the templates as they are in the GitHub stream, and then start maybe figuring out how you could apply that knowledge to other OpenStack clouds or to a production deployment in our cloud. All right. Well, I thank you very much for taking the time, and yeah, if you want, let's grab a beer. Maybe we got a bunch of DevOps guys here. Love to maybe play around with Heat if you want to see it, or if you're curious about any of these other things. So just come grab us. We're over there having a beer and probably talking about computer stuff. So thank you very much.